Welcome to the Explainer. Today, we are taking a seriously epic journey into the hidden mechanics of the internet. We're going to uncover exactly how our computers manage to navigate this unimaginably vast digital landscape, processing literally billions of queries every single day. And it all comes down to a brilliant piece of technology that operates totally silently in the background of everything we do online, the Domain Name System, or DNS.
Think about it for a second. What exactly happens behind the scenes the very moment you type a web address into your browser and hit enter? It feels instantaneous to us, right? But that single keystroke actually kicks off a massive, incredibly fast global quest. And to understand this quest, we first need to understand a fundamental communication problem.
So, let's dive into this core conflict. We humans, we navigate the world using names. We're completely accustomed to using words to identify a person, a country, or a website, like yahoo.com. It's just how our brains work. Computers and network devices, on the other hand, they do not go by names. They talk and identify each other over a network using numbers, specifically what we call IP addresses. You can think of the older IPv4 addresses, which look something like 192.168.1.1, or the newer, massively long alphanumeric IPv6 addresses. So, basically, we have human language on one side and computer language on the other. To bridge this massive communication gap and make our lives infinitely easier, network engineers developed DNS. The Domain Name System is literally the internet's ultimate translator. Its entire job is to resolve the names we type, those domain names, into the exact numbers that computers actually understand, the IP addresses. Without DNS, you would literally have to memorize millions of long strings of random numbers just to check your email or read the news. No thank you. It honestly works exactly like a giant digital phone book. When you want to call someone, you don't magically know their specific number right away. You look up their name in the phone book, and the book gives you the number. DNS lets you look up a website's name, and it finds what's technically called an A record, which then hands your computer the exact IP address it needs.
Let's see how this builds into an actual process. The journey begins checking the cache.
That brings us to step 1, the resolver server. Our data query's hero's journey starts super close to home. Before your computer even reaches out to the broader internet, your web browser or operating system checks its own local cache memory. It's basically asking itself, hey, have we been here recently? Do I already know this website's number? Now, if it doesn't know the address, it sends the query to the resolver server, which acts as your dedicated personal agent. This is typically run by your internet service provider. First, the resolver receives your query. Second, it checks its own much larger ISP cache memory to see if anyone else on your network has recently asked for this exact IP address. If it finds it there, great. But if it can't find it, the resolver escalates the request, venturing out into the wild global internet hierarchy to find the answer for you.
Moving on to step 2, the root servers.
Escalating the query takes us to the absolute backbone of the internet. And the physical scale of this system is just incredible. There are exactly 13 sets of root servers strategically placed all over the world. What's completely mind-blowing is that these are operated by 12 different independent organizations. We're talking places ranging from NASA and the University of Maryland all the way to ICANN. And every single set has its own unique IP address. But here is the really fascinating twist. When your resolver asks the root server for the IP address of, say, yahoo.com, the root server actually doesn't know the exact IP address. It doesn't hold that specific piece of data. Instead, it looks at the very end of the domain name, like the .com part, and acts as a crucial guide. It essentially tells your resolver, look, I don't know the final answer, but I know exactly who you need to ask next, and points it in the right direction.
That hands us off to step 3, the top-level domain, or TLD servers.
Following the root server's directions, we arrive at the top-level domain servers. Now, these servers are managed by organizations called registries, and they are responsible for specific extensions, the part at the very end of the URL. This server stores address information for extensions like .com, .net, or .org. So if we're looking for yahoo.com, the root server directs us to the specific TLD server that manages the entire .com domain. But again, even the .com TLD server doesn't know the exact IP address for Yahoo. It acts as the penultimate step, telling your resolver, okay, you're close, but now you need to talk to the final boss. And finally, step 4, the authoritative name servers. We made it! This brings us to the final destination in our epic quest. The authoritative name server is indeed the final boss. It is responsible for knowing absolutely everything about its specific domain, holding the actual DNS records like that A record we mentioned earlier. When your tireless resolver finally asks this server, it confidently responds with the exact string of numbers your computer has been looking for.
And now we witness the triumphant return. Step 1. Your personal agent, the resolver, finally gets the IP address. Step 2. It speeds back and hands your computer the exact number. Step 3. Your computer, now speaking the right language, connects directly to the website server and successfully retrieves the web page for you to view. Mission accomplished.
But wait, the system has one more really clever trick up its sleeve. As the source material points out, once the resolver receives the IP address, it will store it in its cache memory. This is the true brilliance of DNS. It learns. By saving that IP address, it doesn't have to repeat this whole complicated journey the next time someone asks. But it doesn't save it forever. Technically, this is governed by something called TTL, or time to live. The cache holds onto that number just long enough to be super useful, but eventually forgets it. Why? Well, so that if a website changes its servers, you don't end up stuck with an outdated number. Pretty smart, right?
So let's do a super quick recap of the chain of command we just went through. Your local resolver server at your ISP acts as your agent. It asks the global root servers, which then direct it to the specific top-level domain servers, which finally point to the authoritative name servers holding the true address. That is your complete chain of command from start to finish.
Which really just leaves us with this final, honestly mind-boggling question. We just walked through this massive, multi-server global journey involving checks, escalations, and handoffs between organizations located literally all over the planet. Yet, how does all of this happen in roughly 50 literal milliseconds every single time you click a link? It's an absolute testament to the incredible speed and engineering of the internet. So the next time you load a web page in the blink of an eye, take a second to marvel at the invisible, lightning-fast journey that just happened right behind you.